Okay, I'm just going to do this one by slideshow because there are a couple of concepts I want you to know from here, and then we'll have three different formulas, and I'll write those on the board. Project the projector. Those are really the only formulas we're going to have. This is more of a conceptual chapter. Honestly, we could spend an entire semester on alternating currents, but I don't. I just leave it at that. I don't. Okay, so the idea is we have some alternating voltage source. We've got some kind of generator that's generating an alternating EMF, something that's increasing and decreasing. That could be as simple as that generator I pointed out last time. A rotating coil or a rotating loop of wire in a constant magnetic field will create an alternating voltage. So I've got some voltage. Let's do our simplest case where our voltage goes like a sine wave. It doesn't have to. There are other alternating voltages we could have, but we're always going to deal with sine waves. Well, that will create then an alternating current as well. And in our simplest case, these two will line up. They'll both have the same angular frequency. Remember, think back to your trig class. One entire period is the length of time it takes to get from here to here. Omega is the angular frequency. It's measured in radians per second. And that's if we were to convert this over to radians per second. Okay, our average voltage, this goes up and down and up and down. All these positives cancel out all the negatives. The average voltage coming out of your receptacles, your plugins, is 0. The average of a sine wave is 0. So when we say that the outlet has 120 volts, that's not the average voltage. That's not even our peak voltage, our maximum here. That's this thing we call here the root mean squared voltage. So root mean squared is there are two different ways to think about an average of a function. You could just do the integral from, say, starting to ending and divide by the length of that interval. That's the definition of the average of a function, and here you would get 0. Or you could make everything positive, take the absolute value of this, and then take the average of that, and you would get half the peak here. So that would be what we call the absolute value of the average, which is half of the peak. Or another way you could find something like an average is to square your function. That would make everything positive. And then find the average of that, and then take the square root of that squared average. And that's called the root mean squared value. And it turns out electrical engineers really like to use this value as kind of a representative, typical, or so-called average value. And it's called the RMS value. So, and that is your peak value divided by square root of 2. So when we say your outlet is 110 volts or 120 or whatever you have in your house, that's actually the RMS value, not the peak and not the average. The average is 0. We could do the same thing with current. So the IRMS is your peak current divided by square root of 2. Okay, if we have just a simple circuit, the easiest circuit we can have is we have some kind of, this is our circuit element symbol for an alternating current. Like before, remember we had a battery. This is the alternating version of a battery. So I've got some alternating current here, say it's going like sine, or alternating voltage, goes through this resistor. We just get Ohm's law. I don't know why your book chose to write this like this. I would have written it like Ohm's law. It's our peak voltage is our peak current times R. It's just Ohm's law. Same thing applies for RMS. The RMS voltage is the IRMS times your resistor. Everything's always going to come back to Ohm's law. Okay, that's our simplest type of circuit.